Hi, in this video we're going to talk about the graphs of cubic functions. Let's look at this example. It says, sketch the curves with the following equations. Well, I will have more than one example, this means, right? And show the points where they cross the coordinate axis. Now, first of all, the question says sketch. This means we're not going to have a table of xy, and we're not going to write down, like 7 or 10 values for x and calculate for each y value. We're not going to do that. Instead, we are going to find out the coordinates of the points where this graph cuts the coordinate axis. Basically, the y-intercept and the roots of the equation. So let's give it a try. For x equals 0, we're going to find the y-intercept. Y equals, well, 0 times 0 plus 1 times 0 plus 2. Well, it's going to be 0 times 1 times 2, which is 0. So we end up with the coordinates as 0 to 0. This means the y-intercept is where y equals 0. This is the origin. So we have that. Now, second, we're going to give y equals 0. And then this turns into x times x plus 1 times x plus 2 equals 0 as a cubic equation. And just because it's in the factored form, we can easily write down either x is 0 or x plus 1 is 0. This means x is negative 1. Or, let me write here, x plus 2 is 0. This means x is negative 2. So these are the points where the graph of this cubic function cuts the x-axis. So it is going to be minus 1. So let me place it here. Oops. That's negative 1. This is the origin. And let's say this is negative 2. Now, we have to remember that if the leading coefficient is positive, it will look like this. Meaning, in the expanded general form of a cubic function, right, a is the leading coefficient because it is the coefficient of the x cubed, right, the biggest unknown with the power, right? So that's the leading coefficient. If a is positive, then this will look like an N shape. If a is negative, then we can expect to have something like this. So it's exactly the opposite. Let me have this again. It's gonna be like that. You can see that the N-shaped is reflected upon y-axis. Alright, this is very important. So we have to be careful about how the graph should look like, because finding the coordinates where the graph cuts the axis does not give you the clue. Alright, you have to know how the graph behaves depending on the leading coefficient. So our graph will be the say red one. So that's the graph of this cubic function. Now let's look at this function. Here the difference is that we have x minus 1 squared. Now this is where we have a double root. So let's see what I mean with that. For y is 0, it's going to be x minus 1 squared times x plus 1 equals 0. I can say that x minus 1 squared is 0. This means when you take the square root of both sides, x minus 1 is 0, so x is 1. And on the other hand, x plus 1 is 0, so x is negative 1. Although this is a cubic function, I end up with two roots, apparently, but this is a double root. So I have 3 roots two of which are the same. So I'm going to mark these on the graph. So let's say this is -1, right? And this is 1. Now again, when I check this one out, I mean, if you start expanding it, you're going to end up with x cubed plus something. So we don't know what these are. But this is the x cubed term, and the leading coefficient is 1, which is greater than 0. So my graph will look like an N shape. However, I'm not going to have the x-axis crossed out 3 times. It's going to be only 2 times. Besides, well, let's calculate the y-intercept as well. So when I substitute 0 for x, I'm going to end up with -1 squared, which is 1, times 1, so it's going to be 1. So this is basically 0 to 1. Now, I can also mark this on here, that's the y-intercept. Now, my graph will be an N-shaped graph, so it's going to be something like this. However, here, where x is equal to 1, this is a double root, so my graph will touch the x-axis at x equals 1 and go up. This is something like in the quadratic equations, you know, when you have double root, when you have a perfect square, that's what happens. It just touches the x-axis because there's only one root or two double roots, remember? So it's the same idea. So basically, it's going to be, let me draw properly, something like this, right? Now, just because this is a sketch, we never know where exactly the graph passes through, right? We're not calculating many more points. We're just finding out the graph cutting the coordinate axis, and we're just drawing this, sketching this to have an idea about the graph, right? So we don't expect more, and the examiners will not expect too much, as long as it looks like, you know, the leading coefficient gives you this way of the graph, and you just do it correctly, and you find the coordinate axis intersection correctly, and you have your graph pass through those, everything is fine, right? So another example. Now you may be given an expanded form of a cubic function, but it will be somewhat easier to factorize it. Notice that in each of these terms you have an x as common term, so you can basically write this down as y equals x in brackets x squared minus 2x minus 3, right? And then inside the brackets is a quadratic expression which you can factorize by saying this minus 3 and 1. So you're going to have x minus 3 and x plus 1. So you can easily end up with a factored form when you are given an expanded form like this of a cubic function. So it's not going to be very hard to figure out the factored form. So at this point, what we do is the exactly the same thing. So I'm going to find the roots and the y-intercept like this quickly, and then I'm going to plot these points. It's going to be -1, it's going to be 0, the origin, right? And it's going to be 1, 2, 3 here. So it's going to be this, this, and this. And the y-axis, the y-intercept is 0 to 0, 2, so it's going to pass through the origin. So again, the leading coefficient is 1, which is greater than 0, right? So I'll go with an N shape again. So that's going to be something like this. Again, we don't know exactly where this function passes through the graph, right? It could be something like this. It could be something like this, but it doesn't matter how you end up with this. It could even be something like this, but we don't know and we don't care. As long as your curve passes through those intersections, and as long as you have the correct shape, like n-shaped or like this, right, according to the leading coefficient, then you're good. In this last example, we're going to deal with x minus 2 brackets cubed. Now, the graph of y equals x cubed is basically like this. So you're going to have only one root, so it's awful. Now let's do this. So it basically passes through the origin. Now, we can find out those points for x equals 0, y equals 0, and so that's the y-intercept. For y equals 0, x cubed is 0. This means x is 0. So you have triple root. You have three roots which all of three are the same, which is the origin. So this is the graph of y equals x cubed. Y equals x minus 2 cubed will be, on the other hand, well, we have the y-intercept to be minus 8. Let's say it's going to be here, minus 8. And then the only root we have is 2, which will be here. So the graph will cut the y-axis from, say, y equals negative 8, and it goes through x equals 2. So it basically will be something like, right, so the curve cuts through the coordinate axes as we find them. The y-intercept is minus 8, so it's here, and not this one, x is 2, so it's here, and you just draw the curve as if it is. So if I draw it like this, because of the scale is different, the first graph for y equals x cubed would give you a wrong idea, so I'm going to draw it again. It's something like this now, right, because of the scaling. So basically you just move y equals x cubed graph 2 units to right, which we will describe and discuss this in detail in other videos, right? So it is no big deal, right? So this is how you deal with perfect cubes. Now, just because this is graphing, you're going to work on the exercises on the book, so there is no online self-check, right? And then please show your answers to me. Thanks for watching.